or before we dive into our masterclass, let me just quickly introduce myself. This is Neha Chauhan here. I am a teacher expert at Cuemath with a teaching experience of more than 3 years. The subjects which I primarily teach are mathematics and reasoning, and the regions that I cater to are India and US. Now, all of you who are watching this masterclass, please do prepare yourself up by taking a notebook and a pen with you so that you can jot down the important concepts, important facts, important formulas, if there are any in the masterclass, which you can use for your future references while you're revising these topics for the Olympiad. Now, let's quickly get started with today's masterclass. So the first thing that we have to see in our today's masterclass is the table of contents, which is basically what all are we going to cover in today's masterclass, for which the topic is geometrical shapes. So just let's have a quick look at it. The first thing that we're going to do is to understand what geometrical shapes are. Then we'll see some applications in our day-to-day life of these geometrical shapes. The objectives on which we'll have, on the objectives that we'll be seeing, we'll have problems based on that. Problems of both levels, basic level as well as the advanced level. And then finally, we'll see what are the learning outcomes, what are the takeaways from today's masterclass. So the first thing that we start with is understanding the geometrical shapes. Now, before we do that, let's just have a quick test for ourselves. It says here, identify the shapes marked as P, Q, and R in the given figure. So I hope all of you would be able to see a figure on screen wherein certain shapes have been marked with the alphabets R, Q, and P. What we need to do is to name those shapes. What is the name of those shapes? Now, if you were to look at the given question carefully, we see that R is written inside this shape. Now, this shape is a closed shape, that is, it's not open from anywhere, and it has got 3 sides to it, 1, 2, and 3. So basically 3 sides, and it's a closed shape, not open from anywhere, and this shape is called as triangle. So I hope most of you would have answered this. Now let's go on to the next shape, wherein the alphabet is Q. So here is the alphabet Q. Now this is inside a shape which has now got 4 sides to it. So this is one side, second side, third side, and then the fourth side. So 4 sides, and all of the 4 sides are enclosing this, that is, it's not open again from anywhere. So this shape which has got 4 sides to it, and all the 4 sides, if you would look like that they're all of same length. So basically what do we have? We have got 4 sides in it, and all the sides are of equal length. So we write 4 sides and equal length, and such a shape is called as a square. So the alphabet which is inside the shape, the alphabet Q which is inside a particular shape, that shape is called as a square. Now coming to the last alphabet, which is the alphabet P, let's see what is that shape. So here is the alphabet P. Now this is inside a shape which has got no sides, but it has got a closed circular boundary, and this shape is called as a circle. Now there is a difference between an oval shape and a circular shape. A circular shape is uniform all throughout. Basically, if you would take a center point here, the distance remains same to the outer boundary anywhere if you would take. That is basically from the center point to the outer boundary, the distance at any point in time remains same, and such a shape is called as a circle. So basically we have seen few of the shapes here, but we're going to learn a lot more shapes like this in our today's masterclass. Some plane shapes which are 2D shapes, 2-dimensional shapes, and some more shapes which would be solid shapes, or basically 3-dimensional shapes. So now that we have seen a test for ourselves and we have answered the questions, that is basically what shapes are these, let's go to the concept of geometrical shapes. Now it says here, geometrical shapes can be defined as a figure or area closed by a boundary. So as I was mentioning in the previous question, all the shapes that we were discussing were closed from all ends. They were not open from anywhere. So geometrical shapes can be defined as figure or area closed by a boundary, which is created by combining the specific amount of curves, points, and lines. So it's not necessary that you always have to have lines, straight lines. It's okay to have curves also, which can close a particular figure or a particular area, just as we had seen in the shape of a circle. A circle is not made up of any straight line, but it has got a closed boundary to it, and it is defining a particular area wherein there is no open end. It's closed from all the sides, like from all the directions. If you would see, it's closed from everywhere. It's not open from any side, and hence that also is considered as a geometrical shape. So basically, if an area is defined by a closed figure wherein the figure is created by a certain amount of points, curves, or straight lines, such a shape is, or such a figure is called as a geometrical shape. And such examples that we have already seen are triangle, circle, square, etc. So we'll be learning about all of the different shapes, all of the different plane, two-dimensional shapes going forward in the masterclass. So as I had already told you, that keep a notebook with you and a pen with you so that you can make notes of these shapes and what are their properties. How can you differentiate one shape from another? Now that we have understood the basic definition and we have already understood what geometrical shapes are, we'll go on to see what are the applications of these geometrical shapes in our day-to-day life and why do we need to learn them. So with this, we move on to our next part. So as you all would be able to see on your screen now, we see images which are taken from a home. So we see some furniture which is made up of different shapes. Also we see a carpet and a sofa in the other image. Now here we can locate, or here we can identify a lot of shapes which are incorporated in these furnitures, in these objects which are used in our houses, in our homes. So basically, if you would see, the furniture that we have here has got a table which has got a top like this. So this is a closed figure defining a particular area. It's defining a particular area and it's closed from all ends. So this is a particular geometrical shape. Now, if you would see, the legs also are of a particular shape like this. They also are defining a particular area. So the tables, the chairs, even the doors and the windows, a window might be of this shape, as we all know in our houses. A door might be of this shape. So these are the different shapes that we can identify or we can locate in our houses very, very clearly. So we see that shapes do come in our lives on everyday basis. We see them in a lot of other places as well. Now here, if you would see at the carpet in itself is of a particular shape. It has got a closed boundary like this, and it's not open from anywhere. Now the pattern inside the carpet or the rug also has got geometrical shapes. That is, if you would see, this is like a triangle, then it has also got a smaller triangle. So the pattern is also made up of geometrical shapes. So the patterns that you see in a lot of buildings and a lot of architecture also comes from these geometrical shapes. The windows, the doors, the furnitures, all of these things also are made up of geometrical shapes. So this is something which we see on a daily basis, on an everyday basis, wherein we can understand the application of geometrical shapes. Now that we have understood this, let's see some more applications of geometrical shapes. So as we had already discussed in the previous part about the applications or wherein on a daily basis we see geometrical shapes, let's see some more applications. Now, the biggest inventions in human civilization, if anyone knows, is, if any of you can answer that question in the comment section, we'll be pointing out the answer, who has answered it correctly. So the biggest, or the most important inventions of human civilization was of a wheel, which is basically in circular shape. So I'll just draw a circle right here. So this is a circle, which is a geometrical shape. Now, why is this really very important in human civilization is because when a circle, or primarily what we called it was a wheel, was a very important invention. Or why I would say that wheel was really very important is because what we understood is the property of this geometrical shape. Now, if you could answer what property of this geometrical shape, which is a circle, made it to the wheel and not any other shape? Why did we not have a wheel in the shape of a square? Why did we not have um, a triangle as the wheel? And that is because a circle has got no sharp edges. It is not made up of straight lines. So it makes it easy to roll. It can easily roll over a road or over a plane surface. Whereas if we would have had a triangle as a wheel, it has got these sharp corners, also sharp edges, which are these sharp sides. So that would have made it very difficult for it to roll over a plane surface. It can slide through, but it cannot roll. And rolling makes it faster, for a wheel to move from one place to another place. So the transportation, which all happened, like even in the case of aircrafts, we have small wheels in it. In two-wheelers, in four-wheelers, we've got wheels, and transportation made it all to the human civilization. So wheel was one of the greatest inventions that we had, which was a geometrical shape, a circular shape. And the most important property that we had here was that a circle has got no sharp edges, no sharp boundary, which makes it very, very easy to roll over a plane surface, and hence makes the transportation or moving from one place to another place very fast. Now, this is one of the applications that we have, one of the very important applications of geometrical shapes that we have. Now, another application that you would be seeing is, different ways of packaging food. We have, foods like, your cereals, your cornflakes and everything, which comes in these kind of shapes. They're basically like this. There would be a Tetra Pak, a pack which you can say is, thicker than a cardboard, but, thinner than, thicker than a paper, but thinner than a cardboard. So they usually come in these kind of shapes. Also, if you would see, your cool drinks and a lot of other purees come in these kind of shapes, which is like this. Cans which are of these shapes. So far what we saw was the application of two-dimensional shapes, wherein the shapes were flat. Now, if we were to talk about these are also certain sort of applications when geometrical shapes are coming into picture. But the difference between the triangle, circle, square, rectangle, and other shapes and this is that these are three-dimensional solid shapes. So they've got 3 dimensions to them, whereas the plane shapes that we were talking so far had only 2 dimensions to them, about which we'll be discussing in detail in going further in the master class. So like you see a lot of applications basically of geometrical shapes in wheels, in food packaging, and in your houses that you see, windows, doors, and other places. So these have got a lot of applications in our day-to-day life. And I think and I hope that all of you would have got the relevance of it, of how geometrical shapes are really important and why is it important to study them in detail. Now that we have understood the applications of the geometrical shapes, we'll go on to the next part, which are the objectives. So the basic 2 objectives that we'll be covering in today's masterclass is about types of lines and then shapes and their names. So what are the different types of lines that we have, and then the different shapes that we have, 2-dimensional shapes and then solid shapes, and what are their names, what are some primary and some specific properties that are associated with each shape. So here we start. And before we start, there's again a quick test to all of you. Now that I had already discussed what a circle, a square, and a triangle is, it says that the figure which is given on your screen is made up of how many squares? It's made up of dash squares. So quickly, if you all can count and you can put it in the comment section that how many squares do you see in this figure. We'll see who has answered it faster and correctly. So To answer this question now, let's begin. All of you would have answered by now, I hope, because it's a quick question, not too much to think about. Let's see how many squares do we have. So there is one square right here. So 1, 2, 3, 4. So there were 4 squares at the corners. Then there is a bigger square, which is the 5th square right here. Then we have the nose, which is the 6th square, the eyes, 7th, 8th, and the outer eyes, which is 9th and 10th. So basically this figure has got 10 squares to it. So the answer to this quick test is that the figure is made up of 10 squares. So I hope all of you would have understood this question, because already you know that I had already discussed in the previous quick test, wherein a shape which has got 4 sides to it and wherein it looks like, or it has all the 4 sides to be of equal length, we call it as a square. Now moving on to the next part, that is understanding what types of lines do we have. So the first thing which we have is called as vertical line. So you would see that these lines are standing straight, okay, like how a tree stands standing straight. So vertical lines are also called as standing lines. The next type of lines that we have are horizontal lines. Now horizontal lines you can relate to the roads. The roads that we have, the grounds that we have, they are all plain and they are all lying flat. The surface or the terrace of a house is also flat. So they are made up of a lot of lines connected together. So these lines, which are called as horizontal lines, in a simple language can also be considered as sleeping lines. So vertical lines are called as the standing lines because they're standing straight, and horizontal lines in easy and simple language can also be called as sleeping lines because they are lying flat on a surface and they're not standing, they're not erect. Now the next type of line which we have is called as slanting lines. Now it's neither vertical nor horizontal, so it's somewhere in between of these two. So this is one direction of slanting lines that we can have. There can be another direction as well, which could be of this type, that you can have it coming from left to right, and this is coming from right to left. So, and this is from left to right. So these are slanting lines. Now a lot of students get confused in one concept, which is they get confused between straight lines and the types of straight lines. So a lot of students just consider vertical lines as the straight lines, and then they do not consider horizontal or slanting lines as straight lines. And some of the students only consider vertical lines and horizontal lines as straight lines, but not the slanting lines as the straight lines. So for your clarification and for your better understanding, vertical line, horizontal line, and slanting line, in easy language we can call them as standing lines, sleeping lines, and slanting lines. These are all straight lines. We can put them all in the same bucket of straight lines. They all are straight. These are different types of straight lines that we have. So inside straight lines we have different types, which is called as a vertical straight line, a horizontal straight line, and a slanting straight line. A straight line basically means which has got no bendings in it. That is, it's going straight. It's not bending like this anywhere. So if it bends, then it's not a straight line. So anything which goes straight without any kink in it, without any bending in it, is called as a straight line. So we have vertical line, horizontal line, slanting line, all coming in the same category of straight lines. So these are sub types of straight lines that we have. So I hope now all of you would be clear that whenever in any question, if they ask you to count the number of straight lines, we have to take into consideration all 3 of them, which is vertical, horizontal, and slanting. Now we go on to the next type of lines, which is a curved line. Now there is a difference. Now these curved lines do not form a part of straight lines because we see here there is a curve or there is a kink. So they are bending at certain points. So these type of lines which are bending from some places are called as curved lines. So these are called as curved lines which are not a part of straight lines. So I hope I have made it very, very clear that the first three types that you have seen, vertical, horizontal, slanting, do form a part of straight lines, wherein any line which has got curves, bendings or kinks in it is not a straight line but is a curved line. So that is the basic difference that we have between different types of lines. With this, we move on to the next part, which is the two-dimensional shapes, or which is basically the flat shapes. Now, how do you understand flat shapes? Any shape that you can just draw on a piece of paper. Just you can draw it on a piece of paper and it cannot have, any coming out of the paper is called as two-dimensional shape. So let's have some two-dimensional shapes on screen. So the first one that you see is a square. Very clearly, it has got four sides to it. All the sides are of equal length. So such a shape is called as a square. The next that we have is a triangle. Again, it has got three sides to it. The shape is completely closed. And a triangle, it's not necessary that, you should have all the sides to be of equal length. Now going forward, like students who are of higher grade in today's masterclass, that is grade 4 and grade 5, I think would already be knowing about different types of triangles that we have based on the side lengths. That is, if you have all three sides equal, we call it as an equilateral triangle. Now this is just an extra information that all of you can take down in your notebooks, that if a triangle is a shape which has basically got three sides to it. Now, if all the three sides are of equal length, we call it to be an equilateral triangle. If it has got two sides to be equal, that is, two sides are of equal length and the third side is unequal, we call it isosceles triangle. And if all three sides are of different lengths, distinct lengths, none of them are same or none of them are equal to any other, then that type of a triangle is called as a scalene triangle. So that basically depends on the side length of the triangle. So primarily what you have to understand basically is that what a triangle is. A triangle is a closed figure, not open from anywhere, which has got three sides to it. So any shape which has got three sides to it, just three sides to it, and is enclosing a particular area is a triangle. And then based on the lengths of the sides, we can decide whether it's an equilateral triangle, isosceles triangle, or a scalene triangle. So not to bother too much about the types of triangles now, we'll move on to the next shape, which is a circle. So we've already seen a circle. We've already understood what a circle was at the start of our session. Now just to tell you again, if you would pick the center of the circle, which is exactly in the middle. Now from this center, if you would draw a line to the outer boundary at any point, anywhere, what we see is that the distance, this length, the straight line's length would remain same. It remains uniform, and such a shape is called as a circle. Now we may have something slightly looking like a circle but is not exactly a circle. So this is a shape. Now I take a center of it. Now this distance is not same as this distance, okay, because we see that it is wider horizontally and it's not as much wide as it is horizontally vertically. So there is a difference between this distance and this distance. This distance is bigger than this one, is lengthier than this one. So this is basically called as an oval shape, wherein the circle, you can understand it. A way of visualizing it is you're slightly compressing a circle from one of the sides, either vertically or horizontally. So one of the sides is a bit more wider. It's wider from one of the sides, and it's not as wide on the other side. So that is called as an oval. So this is a horizontal oval. You can have a vertical oval like this. So not a very clear picture, but like, yeah, you can imagine or you can visualize an oval like this. And this is a horizontally sloping oval. This is a standing oval. So that's how we basically understand the difference between a circle and an oval. So circle is more uniform. We go on to the next shape, which is a rectangle. Now, this is what you have to understand very carefully, that this shape is also a closed figure wherein it has got four sides to it. Now, the square also has got four sides to it. So how is a rectangle different from a square is, that in a rectangle you just have the opposite sides to be of equal length. This side is equal to this side and this side is equal to this side. Not all the four sides are of equal length, but only the opposite sides are of equal length. So a closed figure wherein you've got four sides and it has got the opposite sides to be of equal length is called as a rectangle. So basically we can say that all squares are rectangles, but not all rectangles are squares. I hope you've understood this point. It's a bit confusing, but to understand it, you can, I'll reiterate. All squares are rectangles, but not all rectangles are squares. So now that we've understood the difference, the basic difference between a square and a rectangle, we move on to the last shape which we have already discussed, which is an oval, which you can consider or you can imagine by compressing a circle from one of the sides. So this is compressed vertically, so it's become a horizontal oval. If you try to compress a circle from horizontal, like from the sides, not from the top and bottom, but from the sides, it will look like a vertically standing oval. So a circle is more uniform, an oval is not uniform. So now that we've understood the two-dimensional shapes, let's go on to the next part, which is the three-dimensional shapes. So the first thing that we have here is a cone. Now cone is, in a lot of places we have seen cone. Like if all of you can put some applications, some places where you have seen a cone, an object which looks quite similar to a cone in the comment section. We'll pick those answers and we'll see whether those answers are right or not. Now, very, very famous for all you children, a cone you can relate to an ice cream cone. Not the scoop on top of it, but just the ice cream cone, the wafer of it, the wafer that you have at the bottom on which a scoop is kept. So that is basically is in the shape of a cone. So this is a three-dimensional shape. The next that we have is a cube. So a cone also, like another, like if you do not understand it from the ice cream, you're getting confused with the scoop, you can take into consideration the birthday caps that we have. They all also in the shape of mostly in cones. Coming to the cube, cube primarily you would see, or I think the best example that I can give you is the dice with which you play the snake and ladder or the Ludo. That dice is a cube, and in a cube we have all the edges. These are called as the edges, the side lengths are of same length. The next shape that we have is a cylinder. I've already spoken about cylinder. You can imagine it with the cool drink cans that we get, some food cans, like wherein a puree and all of those things are kept. So those are called as that shape is called as a cylinder. Then next what we have is a cuboid. Now cuboid, if I was to tell you, or if I was to give you an example, is basically like a brick. If all of you would have seen a brick is in the shape of a cuboid mostly. Now the difference between a cube and a cuboid again is same as the difference between a square and a rectangle. That is, in a cube all the edges are of same length, but in a cuboid not all the edges or not all the dimensions are of the same length. And then we have a sphere. So sphere, the most relatable example is a ball, a cricket ball or a tennis ball. They're all in the shape of a sphere. So sphere is basically, if you were to relate, now all of these, if you were to relate from the two-dimensional shapes, we can say that a triangle in three dimension would come out to be a cone. A square in three dimension would come out to be a cube. Then we have a cylinder. Then a rectangle would come out to be a cuboid, and a circle would come out to be a sphere in three-dimensional shape. So these are the solid shapes that we are talking about. The previous one which we had were the plane shapes, and they're also named as two-dimensional or three-dimensional. Now that we have understood all of these concepts, what all have we covered so far? We have covered the types of lines, two-dimensional or plane shapes, three-dimensional or solid shapes. We go on to our first problem, wherein the question is, what is the number of sleeping lines, number of slanting lines, and number of standing lines? So yes, so not only should you know the vertical, horizontal, and slanting lines, you should also know the meaning of sleeping lines and standing lines, which I've already told you while covering the concept. So let's see what the shape is, or what the figure is. So this is the figure that we have, which is in some sort of a smiley kind of a shape or a figure. We need to count the number of how many sleeping lines are here, how many slanting lines are here, and how many standing lines are here. So these are the options that we have. So the one which we have highlighted now, if you can see one by one, it's coming on screen. So these are all the ones which are marked in red are 9 sleeping lines. You can quickly count it. The horizontal lines which are lying flat or which are lying down are called as sleeping lines or horizontal lines, and there are 9 in number. The next what we have is the slanting lines, and I had told you, like, it can be coming from left to right or right from right to left. The ones which are highlighted in blue are all the slanting lines, and if you would count, we can see that there are 12 of slanting lines. The next that we need to count is the standing lines. So the ones which are highlighted in green are the standing lines or are the vertical lines. So how many vertical lines do we have, or the standing lines do we have? All the ones which are marked in green, and we have 8 standing lines. So the correct answer to this question would be 9 sleeping lines, 12 slanting lines, and 8 standing lines. So the correct answer to this question is clearly option B, 9 sleeping lines, 12 slanting lines, and 8 standing lines. I hope all of you would have understood this question. With this, we move on to our next question. It says, how many straight lines are required to make the given figure? Now again, do not make a mistake of not counting the slanting lines as the straight lines. As I have already mentioned, sleeping lines, slanting lines, and standing lines, they all form a part of straight lines. So we need to count all the straight lines here. So these are all the options that we have. So this is the first one, then second, third, fourth, fifth, sixth, seventh. They're getting highlighted one by one. 10th, 11th, 12th, 13th, 14th, and the last one, which is the 15th. So they are basically how many straight lines? It all got highlighted one by one. So there are 15 straight lines. So the correct answer to this question clearly becomes option A. So while we are counting straight lines, we need to count all of them. Vertical ones, the horizontal ones, and the slanting ones. We move on to our next question, which is, which of the following figures does not have a line of symmetry? So I guess a lot of you would have not heard the word symmetry, or what does it basically mean. So symmetry is basically if you have a shape and you fold it across one line. You take any line across the figure, okay? And if you make a line and fold over that line, you fold that shape over that line, if it completely overlaps, one part completely overlaps the other, not being lesser or not being more, it should, perfectly fit one over the other, should not exceed and should not be less than that. That is called as a symmetry. And the line over which you fold that shape is called as the line of symmetry. So basically, if you have a figure in front of you, a geometrical figure or any figure for that matter, if you draw a line, by drawing that line, if you are able to divide that figure into 2 congruent parts or 2 exactly similar parts, which look exactly similar as the other, like the 2 should be the equal halves, and those 2 can overlap on each other, that is called as the line of symmetry. Now let's quickly understand it. So these are all the options that we have. We have different figures here. We have a triangle, a rectangle, a square which is a bit tilted, and then we have another figure here. So we need to find which of the following figures does not have a line of symmetry. So we'll start with option A. So we drew a line which split or which divided the shape into 2 exactly equal triangles. So if you would try to overlap, or if you would try to bring one of the parts over the other, it would completely fit. It will not exceed or it will not be less in any in area or in shape or anything. It exactly fits one over the other. So it does have a line of symmetry. And then in the second option, which is a rectangle, we drew a horizontal line, which is again dividing the shape into 2 exactly equal or exactly similar shapes. So it also has got a line of symmetry. It also has got another line of symmetry. So it has got 2 lines of symmetry. One was a horizontal line of symmetry, and the red one which you see now is a vertical line of symmetry. So the horizontal was dividing it into 2 rectangles, like which are lying flat, sleeping rectangles. And then we have this one, which is basically, it looks like a square but is not a square. It again is a rectangle only. So we have got 2 lines of symmetry. There are 2 ways you can fold the shape, which is a rectangle, in option B. which will bring the symmetry. Coming to option C, it has got, you can see one line of symmetry like this and the other line of symmetry like this. So now let's see in option D. We draw one line like this. So it will create two shapes which will not be similar or will not be exactly equal to each other, will not be the replica of each other, the copy of each other. So this is not a line of symmetry. We take another line through another vertex. Again, it is not a line of symmetry. Not even this one and not even this one. So from no vertex that we drew a line could we get two shapes, two parts which were exactly the replica of each other or were exactly the copy of each other, so that if you overlap one of the parts onto the other, it completely overlaps it. So option D has got no symmetry, and hence the correct answer to this question is option D. We move on to our next question, which says, how many sleeping lines are there in the following figure? So now to make a note here or to observe or to understand very clearly is, they are not now asking us about the straight lines. They are very specifically are asking sleeping lines. Now sleeping lines are also called as the horizontal lines. So let's see what the options are. So these are the options that we have here. Now let's see how many sleeping lines do we have. So 1 and 2. We have highlighted it one by one. Then apart from all of, so there are two sleeping lines because there were only two horizontal lines that we could see in the star. So the correct answer to this question clearly becomes option C, which is 2. But if you could tell me the other lines which are there in the star are of which type? Are they horizontal, are they vertical, or are they slanting? Horizontal, vertical, or slanting? If you can put that in the comment section, we'll see how many of you have understood the types of lines very clearly. So the ones which are highlighted already in red are the sleeping lines, and so to this question particularly the answer is 2. But the rest of the straight lines are basically the slanting lines. They are all slanting lines, leaving apart the red highlighted sleeping lines. The rest of the straight lines are all slanting lines. With this we'll move on to, okay, so it has already said here sleeping lines. We'll move on to our next question, which is problem on shapes. So it says identify all the shapes in the figure. So we have all of these options: rectangle, square, and triangle, then triangle, rectangle, and oval, circle, square, and triangle, circle, and triangle. So let's see. So the ones which are getting highlighted in red are 4 triangles that we have in the given figure. The next what we have in green, which is highlighted, is a circle. And the next what we have is highlighted in blue, which is a square. So in this figure, we basically have 3 types of shapes, which is a triangle, a circle, and a square. So if we were to look at the given options, we would see that the correct answer to our question, which is asking the types of shapes, is option C, which has got circle, square, and triangle in it. So the correct answer to this question is circle, square, and triangle. A circle is, has got a curved boundary and it is quite uniform. That is, from the center of the circle to any point on the boundary, the distance remains same. It's uniform. Triangle, as we have already learned a lot of times, is a closed figure which has got 3 sides to it. A square is a closed figure which has got 4 sides to it, having all the 4 sides of equal length. So with this, we move on to our next question, wherein we again have a figure which looks like a house, and it asks us how many squares and circles are there in the given figure. So let's see. In here, these are the options, that is, squares coming first and then the circle. So that is the order in which you have to answer. Every digit that you see which is coming first is basically trying to tell you the number of squares, and the number of digits which is coming after the second digit or the second number is basically the circles that you would try to answer in the question. So now let's first count. So there are 2 squares here, and then next we have another 2 squares, we have 2 more squares, and we have 2 more squares. So basically 2 plus 2 plus 2 plus 2, that is basically 2 being added 4 times. So 2 times 4, which is 8. So there are a total of 8 squares in the given figure. Now let's count the circles. As you all can see, we have highlighted in here blue. These are the 3 circles that we have in the figure. So how many squares and how many circles? We have got how many squares and how many circles? We have got 8 squares and 3 circles. So the correct answer to this question becomes option B. I hope all of you would have understood how to identify shapes and how to count them. Now that we have answered this question, let's move on to our next question, which says, which of the following shape is not present in the given figure? So it is basically formed of a lot of shapes, that you would be able, I'm not answering that, but you would be able to identify the different shapes that we have in this figure. But the question here is, which of the following shape is not present in the given figure? And the options are a cylinder, a triangle, rectangle, and an oval. So which of the following is not present? So the first one, which is getting highlighted in red, is a triangle. Then the next which we have is an oval. Then what we have in purple being highlighted is a rectangle. And then purple, there are two purples, two shapes which have got highlighted in purple. Both of them are rectangles. And then there are two which have got highlighted in green. They both are squares. The windows are basically the squares. So the one which we do not have very clearly is a cylinder. Also, what we need to understand is it's a 2D figure. It's a two-dimensional plane figure which is there on your screen. And a cylinder, as we have already studied, is a three-dimensional shape. So that would not be present anywhere in this figure and is clearly not here. And so the answer to this question becomes option A, which is a cylinder. With this, we come to question number 4, which says, which two shapes do not intersect each other? So we have a circle, oval, a square, and a rectangle. There are different shapes that we have in this given figure, and many of them are not intersecting each other. So how do we answer that? So we'll have to look at the options. So these are the options that we have. We have to go by each option and see whether they are intersecting. By intersecting is that at any point in time, the word intersect means at any point in time, whether one shape is crossing the other, even, partially, completely, slightly. If it's touching or if it's crossing another shape, we call it as intersecting. So the first option that we have here is X and Y. So this is X and Y. So X is this shape, which is a rectangle, as you would see, and Y is this oval shape. So at no point or in no place are they, touching each other or crossing each other even slightly. So they are not intersecting each other. That's what we would say. Now, so option A could be one of the correct answers. Let's go over the next set of options as well. So option B is basically asking W and X. So W is this tilted square, and then X is this rectangle. So we see that they are crossing each other at this place. This is where they're crossing each other. So yes, they do intersect. W and X intersect. W and Z. So W again is this tilted square, and Z is basically this circle. So they also are intersecting here, crossing each other at this place. So they are intersecting. Then next, what we need to check is Z and Y. So this is Z, which is your circle, and Y, which is the oval. And yes, they are intersecting at this place. So they also are intersecting. So the only two shapes in the given options which are not intersecting at any point in time are X and Y. So the correct answer to this question becomes option A, which is X and Y. So I hope in this question, what is very important to understand is the meaning of the word intersect. So I think I've made it very clear. Any two lines or shapes or solid shapes, if they're crossing one of the other, or are touching touching each other at even slightly or completely or partially, that is called as intersecting. So X and Y are not intersecting, whereas the rest three of the options have got the shapes intersecting. So that's how we answer this question. With this, we move on to our next question, which is count the number of circles in the following figure. So here we have a lot of circles, and we need to patiently sit and count the number of circles. These are all the options that we have. Now let's start counting. So this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, then 20, 21, 22, 23, 24, 25, 26, 27, 28, 29 and 30, and then 31, 32, 33, 34, 35, 36 and 37. So we basically have got 37 circles in here. All we needed to do was just to count the number of circles that are present in the given figure. So the answer to this question becomes option B, which is 37. With this, we move on to our next question. Okay, so this is an advanced level question here, and it says, the model of a tower shown is made up of unit cubes. Cubes we already know, which has got the edges or the sides of same length, stacked on top of each other. How many unit cubes in all are used to form the tower? So here we will need a bit of visualization. So let's see what the options are. So these are all the options that we have. Now, how do we count the number of cubes? So there are cubes which are visible to us, but there would be some cubes which are not visible to us in this tower, which is made up of stacking of the cubes. So this is a cube at the top of the tower. Okay, so this has got one cube. Now there would be one cube right below this. So the layer which is right below this has got three cubes in it, which is this cube and this cube, and the cube which is not visible to us, which is right below the green cube. So this layer has got 3. Then coming to the third layer, so we clearly see 3 cubes right in front of us, which are these: 1, this one, 2, which is this one, 3, which is this one. Now again, what we need to understand is there is again another cube which is right below the green one, and then below the yellow ones as well. So 1 from the green and 2 from the yellows, so that is 1 plus 2, which is 3, and then 3 of these blue. So 3 plus 3 basically gives us 6. So this has got 6. Now coming to this one, the next layer, we have these cubes clearly visible to us. So this is 1, 2, 3, and this is 4. So 4, and then there would be 3 right below the blue. So I would add 3 here. 2 would be right below the yellows. So I would write 2 here, and then 1 right below the green. So I would add 1 here. So this layer has got 4 plus 3 plus 2 plus 1. So 4 plus 3 is 7. 7 plus 2 is 9. 9 plus 1 is 10. So this layer has got 10 cubes to it. Now we move on to the last one, which has got 1, 2, 3, 4, 5. So this has got 5 cubes, and it will have 4 from the red ones, 3 from the blue ones, 2 from the yellow ones, and 1 from the green one. So basically I write 5 plus 4 plus 3 plus 2 plus 1. So 5 plus 4 is 9, 9 plus 3 is 12, 12 plus 2 is 14, 14 plus 1 is 15. So basically this has got, the last layer has got 15 cubes to it. So I hope you understood, they're stacked one above the other or one below the other. If you were to start from the lowest of the layer, on top of that we have built the other layers. So there are cubes which are not visible to us but are there in this tower, and that's how we have got the count for each layer. So the first layer, we'll start from the bottom layer. The bottom layer had 15. The bottom but one had 10. Then we had 6 plus 3 plus 1. So 6 plus 3 is 9, 9 plus 1, which is 10. So if we add all of these, so we have 5 here and 3 here. So basically there are 35 unit cubes which are used to form the tower. So the correct answer to this question becomes option C, which is 35. I hope all of you would have understood how did we visualize this question of, so this is a bit tricky. What most of the students might do is that, they would just look at the cubes which are visible to us on screen or on the paper, and they would just count that and would answer the question, but that's not the correct way of doing it. You also have to visualize that where the top cube is stacked on what it is stacked. It is stacked on the cubes which are coming from the bottom layer. So there are cubes which are not visible to us but are there in the tower, and that's how we have to count them. So with this, we come to the last part of our today's masterclass, which is the Olympiad, which says the learning outcomes. And let's see what are the takeaways from today's masterclass. So basically what we understood is identifying basic shapes and lines, different types of shapes that we had: circle, square, triangle, rectangle, oval, different shapes, different 3D shapes like the cylinder, cone, sphere, cuboid, cube, and different types of lines. Straight lines has got three categories to it, three subcategories to it, which is a standing line, a sleeping line, and a slanting line. And then we have a entirely different category, which is the curved lines. And then we understood how to analyze the diagrams and find answers according to the question, and recognize shapes in real environment. We've seen, like, food cans, birthday caps, ice cream cones, windows, doors, wheels, a tennis ball or a cricket ball. These are different places where we visualize and we identify the shapes which we have learned in today's class. So I hope all of you would have found today's class quite engaging and interesting. And with this, it's a wrap for today's masterclass. If you have any questions, any queries with the questions that we have solved, please put it in the comment section and we'll address all of your queries. And yeah, we'll see you all in the next Olympiad level masterclass. So as we all saw in today's masterclass, how logical reasoning inculcates the ability to think logically in a child, they start thinking in an innovative manner. They also strive to get to the answer in the shortest possible way. And this is exactly how a student gets trained by a Cuemath expert, and all of it is being provided in Olympiad masterclasses by Cuemath. So with this, I would like to introduce the TUCO registration forms. Every student who wishes to take up the real-time Olympiad examination by Cuemath, please go ahead and click on the link given in the description box below. The registration amount for TUCO is Rs 200 only, and the benefits that you get on registering for TUCO is that you get a complete course curriculum to prepare for it, which is worth Rs 5,000. So every time we have a masterclass, an Olympiad masterclass as we had today, which is scheduled, you can join us there and then later can work on extensive sheets on the same topic through the course curriculum provided when you register for TUCO. So make sure you do not delay and register yourself to get the most out of the curriculum worth Rs 5,000 just for Rs 200. And